Okay, so how do we complete the square? It might have been a while since you've completed the square. We've got this. This is going to be a polynomial, x squared minus 3x plus 1. It's going to be a parabola facing up. And we want to discuss the results in terms of power series. Okay, so here's what we got here. So we've got our p of x equals x squared minus 3x plus 1. The next step is to, in completing the square, we're going to add in what we're missing, right? So you take this middle coefficient, which is negative 3, and you divide it by 2 and square it. And that's what you need to add to complete your square. Okay, but to compensate for that, I have to subtract 3 halves squared. Okay, and then the plus 1 is just stays as plus 1. And so this square that I completed is down here, right? So it's x minus 3 halves quantity squared. And then to get the minus 5/4, I just simplified that constant at the end. So I have minus 5/4. Okay. So now how is x minus 3 quantity squared minus 5/4? How is this a power series? Well, let's look. We can write it as a power series by figuring out what the coefficients are. So right off the bat, it looks like, based on the way we've written it here, the center of our series, so the center is going to be at 3 halves because it's x minus 3 halves. So the center is at 3 halves, and then to get those coefficients, we just write out our, this might be slightly confusing, so let's write out here. So
It's
remember,
10 hours.
thank you. We have p of x equals negative 5/4 plus x minus 3 halves quantity squared. All right, so that's what we have. And the idea is to see how is this a power series. Well, our first term is negative 5/4. Second coefficient is 0. The third coefficient is 1, right? And then the rest of the coefficients are 0. So the a sub n are equal to 0 for all n greater than or equal to 3. And in fact, if you have a power series and there's some point at which all of your coefficients are 0, that power series has to be a polynomial, right? So you'll see this is not just a coincidence. This happened with our last example as well. And so what's the conclusion? The conclusion is that we can look at this polynomial, right? And what is our polynomial? Our polynomial is x squared minus 3x plus 1. And we can write it in two equivalent ways. And what's the difference between the two equivalent ways? The difference is where your power series is centered. Okay, so for this first one here, we're actually centered at the origin, which would mean that we would consider, it's like you're looking at it like, okay, here's my focus point. Let me actually do a little something here differently. Okay, so this is how I would draw it. I would say, okay, here's my center, and then, right, because like this, my center is the origin here, so my center is at 0, right? And then if I want to look at what's the behavior to the left and to the right, it's looking something like that, right? And I'd say, okay, I don't know what's going on over there, and I don't know what's going on to the left, but that's what's happening, right? So that's my center. If I'm looking on some domain, that's the center of my interval is at 0. Whereas for the second one over here, which is when we write it, when we complete the square, what we've been doing all this time is recentering the power series. So here, the center is at 3 halves. So here, my focal point is at 3 halves, and I'm saying here's my C. Says here. So here's C. And if I'm going to the left or if I'm going to the right, it's like the center of my screen is the vertex. So in our second example, we are recentering the power series at the vertex of the parabola.